Okay, advent of code day 6. Okay. Let's get our input. Looks like it's going to be broken up in a similar way to the passports. Okay. 626, yes, no questions. Okay. For each of the people in their group, you write down the questions which they answer yes, one per line. For example, each group's. Okay. Count the number of questions to which anyone answered yes. What are the sum of these counts? Cool. All right. So we need to break into groups first, and then we need to see how many yeses we've got. Okay. So let's just do for. This is going to be file to list, not ints. For line in L. Group is equal to this. For line in L, if line is, well, if there's something in the line, else, then group is equal to dot append line. Otherwise, print group is equal to, let's add a new line at the very end, just to make sure that that works, and then we're going to say group is equal to that. Okay, so let's see if this successfully breaks up our thing. And it's not. That didn't do what we wanted to. Oh, well, we printed L at the end. That's what happened. Okay, looks like we got the groups that we want now. Let's just look at the very end. Oh, we didn't quite get this last guy. But it looks like otherwise we're doing okay. RC, E, and W are in a group together. Okay. A, and there's our last group. Cool. Excellent. Love it. Okay, we've got our groups. So, this is the place where we have the group. So, in each group, we essentially just need to see all the unique characters. So I'm just going to iterate, I'm just going to say char is equal to set for P in group, for C in P, chars dot add C. And then we're just going to print, and then we just need to, well, we want the sum, so we're going to say counts is equal to 0. And so this is going to be the size of that, so counts plus equals chars dot length of chars, and then we're going to print counts at the end. Six, 5, 4, 2. A part 2. Okay. To which everyone answered yes. Great. Everyone answered yes. Great. So this is part 1. Let's just copy this and then do part 2. Counts as 0, and now it's no longer Now we need to take the intersection of all those sets. New chars equal to set, and let's hope that these sets have an intersection function for CMP new chars. We want this to set, okay, this just needs to be the first one. So I'm just going to say chars is equal to 0, and now this is going to be if chars equals 0, chars equal to new chars. Else chars equal to new chars dot intersection with chars. And then I think this is actually exactly the same, so let's just run this here. Yeah. Wow, we did that second part really quickly. 369. Hey, that's the best rank that I've gotten so far. Let's take a look. Leaderboard. Personal stats. Yep, 369. We did that second part really quickly. I'm kind of curious how fast the top 100. A minute 27. Man. $435 and $229. So I was a little bit slow on the first half, which this is a new way of splitting up the groups that I haven't tried before, but it worked really well. But this intersection thing, that's exactly what we needed. I'm curious if there's a way of just intersecting a bunch of different sets. Just like, oh, probably reduce function, but reducing would require... Oh, well, but we need some sort of a initial value. We could just use p of 0 for that. Okay, I have an idea for how we're going to clean this up. So the first thing that we're going to do is we're going to no longer have these be entirely separate blocks because all of the for stuff is just completely the same. So let's just have count p1 is equal to 0, count p2 is equal to 0, and then we're going to print out oops. Okay, and this is now there. All right. So the first thing I'm noticing is that what we really want is we want this group to be a list of sets and not just a list of strings, because that's kind of annoying. We want to be able to do the union on these different things. So instead what we want to do is convert this line into a set. So let's, I'm just going to quickly search string to array in Python. Oh, we just hand it to the list function. That's good to know. Okay, so we've got list of line, and that gives us a list of things. And then we want it to be a set. So we can do the intersection. So we're just going to turn it into a set. So now, instead of having a bunch of lines, we're going to have a bunch of sets, and that's going to be our group. And that's exactly what we want. So now to find the union of all of those, we can do a reduce. And we're going to say count p1 is equal plus equals length of this set they're about to make. Let's just call it union is equal to, let's see here. Oh, I forgot what to import for reduce. Python reduce. I think it's like functools.reduce. Is equal to reduce. And then first we hand in the function, and it's lambda. And we want the function to take in it's the accumulator and the other value. So let's call this because I guess the order doesn't matter that much. X, Y. And we're going to just take x.union of y, and we're going to pass in group, I believe. So group is our list of sets, and then what's going to happen is each of these sets is going to be unioned with each of the next ones, and then we also want an initializer. Which is going to be just set, the empty set. Okay. Length of union, and then let's do the same thing with the intersection. So and now instead of initializing it with the empty set, which would just cause it to be nothing, we need to initialize it with the first element of the group. Group dot, oh, how do we just get an arbitrary element of the group? Because I don't really care if it's random, I just want an item. Okay, so pop removes and returns an arbitrary set element. That's actually exactly what we want. Because if we were to just grab one and not remove it, then it would be done twice. It would intersect with itself, and that's just a waste of a cycle. It's not super important, but I'm happy with that. Group.pop. I need to remember how that pops can work on sets. I'm so used to thinking about them with stacks. So I'm pretty sure we can just ditch all of that. This is going to be count p2, and this is going to be intersection, and then get rid of that. And we still want this thing, And now let's print this. Let's get rid of all that. I'm just gonna comment it out in case something goes terribly wrong. Run. Oh, good. I know I did this in one of my previous solutions. There it is, from functools, import, reduce. Fine. Six, 5, 4, 2, 3, 2, 9, 9. Hey, that went just fine, and I like how clean it looks now. So we had to do a few things to make this work. So the first thing that we did was we made sure there was an empty line at the end of this, because what this does is it says, hey, if the line isn't empty, I want you to append to this group object. So the group object starts, or group list. The group list starts as nothing, it's just empty, and then every time it sees something that is a non-empty line, it adds to the group list. Every time it sees an empty line, it says, okay, cool, I must be done with this group. Let's do the math, let's reset the group to empty, and keep going. So we had to make sure that there was an empty line at the end. Otherwise, if there was an empty line at the bottom here, then this group right here would be loaded up inside of group, and then this block wouldn't get triggered because there would be no empty line to trigger this block for the very last group. Okay, and then what we did was we did a reduce to find the union of all the different sets, and then we did an intersection to find the intersection of all the different sets, and that gave us our answer. It's nice to see these really classic coding concepts being demonstrated. It's interesting because like all of the yes/no answer questions and stuff, it's all just kind of a icing on top of the thing, which is unions and intersections. Cool. Well, I'm pretty happy with this, and I'm going to get this submitted, and I will see you tomorrow.